Good morning to all. My name is Yashashvas. I am studying first year BTech Electrical and Electronics Department in S. Srinivasa Ramanujan Institute of Technology at Anantapur. Today my topic about compression ignition and spark ignition engines. Introduction of spark ignition and compression ignition machines. Spark ignition engines and compression ignition engines are the two main types of internal combustion engines used in vehicles today. SI engines ignite the air, air fuel mixture with a spark plug, while CI engines compress the air until it reaches a high enough temperature to ignite the fuel. Both types of engines have their own advantages and disadvantages in terms of efficiency, emissions, and performances. Working principle of spark ignition engines. In spark ignition engines, the air fuel mixture is drawn into the combustion chamber and compressed by the piston. A spark plug then ignites the mixture, causing a controlled combustion that drives the piston down and generates power. Spark ignition are commonly used in gasoline powered vehicles due to their smooth operation and ability to produce high power outputs. Working principle of compression ignition engines. Compression ignition engines rely on compressing air in the combustion chamber to high pressure, which causes the air to heat up significantly. Fuel is then injected into the hot pressurized air. Consumption occurs spontaneously without the need for a spark plug. Compression ignition engines are known for their fuel efficiency and torque output, making them ideal for heavy duty applications like trucks and industrial machineries. Fuel efficiency. Compression engines are generally more fuel efficient than spark ignition due to their higher compression ratios and linear air fuel mixtures. The efficiency of a compression engine is further improved by the use of turbocharging and advanced fuel injection systems. Spark ignition engines are catching up in terms of fuel efficiency with technologies like direct injection and variable value timing. Emissions. Spark ignition engines tend to produce lower level of nitrogen oxides and particulate matter compared to CI engines. However, spark ignition engines emit higher levels of carbon dioxide and unburned hydrocarbons due to their fuel-rich consumption process. Compression ignition engines have made significant advance in reducing emissions through the use of exhaust gas and particulate filters. Performances. Spark ignition engines are known for their smooth and responsive performance, making them popular in sports car and high performance vehicles. Compression engines, on the other hand, excel in producing high torque and low engine speeds, making them ideal for towing and hauling heavy loads. The performance of both types of engines can be further enhanced through tuning and modifications. Consumption process. In spark ignition engines, the compression process is controlled by the spark plug, resulting in a more predictable and stable consumption. Compression ignition engines rely on the auto ignition of the fuel, which can lead to variation in consumption timings and pressure. Both type of engines can be benefit from advanced engine management systems to optimize the consumption. Maintenance. Spark ignition engines generally require more frequent maintenance due to the wear and tear on spark plugs, ignition coils, and other components. Ignition engines have longer service intervals and lower maintenance costs thanks to their simpler design and robust construction. Proper maintenance of both types of engines is crucial for ensuring reliable performance and longevity. Future trends. The automotive industry is shifting towards electrification with a focus on hybrid and electric powertrains to reduce emissions and improve efficiency. Spark ignition engines are being downsized and turbocharged to meet stricter emissions regulation without compromising performance. Compression ignition engines are evolving with the adoption of cleaner fuels like biodiesel and renewable diesels to reduce their environmental impact. Conclusion. Spark injection and compression injection engines have their own unique characteristics and applications, catering to a wide range of vehicle types and uses. The future of internal combustion engines is shaped by advancement in technology, regulation, and consumer preferences. As we move towards a more sustainable transportation future, the development of SI and CI engines will continue to play a significant role in meeting our mobility needs. Thanking you for giving this great opportunity.